All right, we are picking up where we left off yesterday. So we're going to take a look at this one. What do I not like about my denominator?
7 minus p.
Yeah, the 7 minus p. What do I not like about that, though? The order. Good. Okay, I don't want the 7 up front. I want the p up front, so I'm very quickly just going to rewrite this. I'm going to take the negative p and then put plus 7. Okay? Now, I want to factor my numerator and denominator. Okay, my numerator is specifically what? What do I call that? Perfect. Difference of squares. Okay? I've got plus 7 and minus 7 in those parentheses. P plus 7, P minus 7. And what else do I not like about the denominator? That negative out in front. So I'm going to divide out a negative 1. And that's going to change the signs. That negative p becomes a positive p. And the positive 7 becomes a negative 7. Good. Now, before I divide anything out, okay, I am going to identify my excluded values. What do I look to do my excluded values? The bottom, the denominator, anything that has a variable. So what's the one number that I cannot have here? A 7. Because if I plug in a 7, 7 minus 7 is the 0, right? Okay. All right. Now I want to see what's it like on the top and bottom. The p minus 7s, they can go away. And y'all, all I have left in the denominator is a negative. So I'm just going to give that negative to the numerator. And we don't have to have it written as a fraction anymore.
If you did have a written expression, would it be wrong?
No. Now, I don't know if the software system will accept that, but I could potentially go back in and give you credit. There's nothing wrong with that. It's just technically not written in simplified form. Okay. Next, right here, I have 2r squared minus 2r minus 40. I see a GCF. I'm going to divide that 2 out. R squared minus r minus 20. Okay, how does that factor, that quadratic? What do I multiply to give me negative 20 but add to give me negative 1? Something with 5 and 4. So 5 and 4 is correct. Do what? Yeah. All right, here we go. Did you figure out which one is positive, negative?
Yeah. 2. 5 and 4. Oh.
Out of 5 and 4, which is positive, which is negative?
5 and 4. No, which 4?
Okay, we're factoring this. We factored out the GCF of 2.
Okay.
Now we're factoring this remaining quadratic. Negative 5 and positive 4. Y'all had all that time. What did I go to college for? Math education.
Making sure.
Are you talking about just like counseling or whatever?
Nah, just in general.
No, math. And then curriculum and instruction for all my other 3 degrees.
33?
My other 3.
Oh, 36.
I have 4 degrees.
I need to go to
You so funny. Y'all act like a teacher with a doctorate makes a lot of money.
They don't. So I need you to go to them. So you got your specialist too, right?
I got my bachelor's, which is your 4-year degree. I got my master's, then I got my specialist, and then I got my doctorate.
So quick question.
Wake her up.
So we talking about work.
Master's is normally like 1 to 2.
So 4 plus 22. So quick question.
All right, I'm recording, so just FYI. Okay, sounds good. All right, here we go. In the denominator, I want to factor out the GCF. What can I take out there? An 8. And that leaves me with R plus 4. Okay, now before I cancel anything out, okay, I have the R plus 4 that I need to look at for my excluded values. So right here, what is R not allowed to equal? -4. Yeah, it's the opposite, because when you plug in the opposite in there, that's going to kind of cancel everything out. Now, I have the R plus 4s that cancel, but that's not all I can do. What else? The 2 and the 8 reduce like a normal fraction, and that would be 1 over 4. So my final simplified answer is R minus 5 over 4. And I'm done. Okay? Now, we will come back to this, but just making a connection, when we graph this stuff, okay? When and if we graph this stuff right here. If I cancel something out, it leaves a hole in my graph. But if something, an algebraic expression, remains in the denominator, then I've got a vertical asymptote there, okay? Some of you know what I'm talking about. Okay, all right, here we go. Let's multiply and, and divide. And we're going to do this fairly quickly because I need to catch us up. Okay? All right, now when I multiply fractions, there are 2 ways that I can do this. Okay? You can multiply straight across. So that gives me 6 over 24. And then you can reduce. That gives me 1/4. Or you can simplify first, then multiply. So right here, the 3/4 doesn't reduce. 2 over 6 does. That becomes 1 over 3. But if you notice, you've got a 3 in the numerator and denominator. So that becomes 1s. And then multiply straight across, and you still get 1/4. You can simplify vertically or diagonally. Either way is totally fine. Okay? So, either way, whether you multiply then simplify, or you simplify then multiply, you're still getting the same answer. Now, when we do this with rational expressions, okay, now this is just my recommendation, okay? If it has monomials only, now monomials are just those single things, like there's no addition or subtraction. If I have monomials only, okay, I first would multiply them together, and then I would simplify. But if I have these binomials, trinomials, that's this stuff that has the addition, subtraction, okay? I personally would simplify everything first and then multiply what you have left. Now, binomials and trinomials, you do need to make sure that you factor before you simplify. Okay, so here we go. Let's hop, skip, and jump around. Right here, for this one, these are monomials. They're single pieces up in the numerator, denominator, okay? This gives me 60 x to the 5th, y to the 7th. Why do I have x to the 5th, y to the 7th? What did I do? You added those exponents, yep. Okay, and then 2 times 18 is 36. Then I have x squared y to the 4th. All right, now what do you automatically see that you can reduce out of the 60 and 36? A 6. Okay, that leaves me with a 10 over a 6. But do we see that I can still reduce that a little bit?
Yeah.
What can you divide out there? A 2. So that leaves me with a 5 over 3. Then we have these x's that we need to simplify, and we have these y's. Now I want you to think I've got 5 x's on the top and only 2 on the bottom, and those are like 1-for-1 cancellations. How many x's do I have left and where? 3 on the top. There's more up top than the bottom, right? So there's still going to be more up top. And then what about this? 3 on the top. Okay, so on the top I've got 5 x cubed, y cubed, and then that's all going to be over 3. All right, so this is my simplified expression. Now, if I asked you here what my excluded values are, I need to specifically say that x cannot be 0 and y cannot be 0. Because those are my variables in the denominator, okay? So we just got to make sure that we protect those from being 0. Okay, I tell you what, let's do this one with monomials real quick. Okay? Now, real quick, I could multiply all these numbers, but that does give me really big numbers. I could simplify this 4 and this 12. That gives me a 1 over a 3. And then I could simplify this 5 and this 15. That also gives me a 1 and a 3. So this is what I'm going to do. 1 times 1 is 1. Then I have a to the 5th, b to the 8th. And then I've got 9. There's an understood 1 with that a. So this is a to the 5th and b to the 10th. Okay, so we've already got the 1 over 9, but I've got these a's right here. What happens to those? They just straight up cancel out. And then I have 8 b's on the top and 10 on the bottom. What's going to happen there? Okay, so I end up with a 1 in the numerator, and then I have 9b squared. What are my excluded values here? Both a and b cannot equal 0. Okay. All right, this is where I'm going to hop, skip, and jump around a little bit. Okay. Let's see. I am going to start right here. Okay. Right here, what do I not like about this numerator? It's out of order, right? It's not in standard form. So I'm going to rearrange this real quick. Okay? Jenna, pick your head up, babe. Okay, out of this, I am going to take out a GCF of negative 5v because I do not like a negative leading coefficient. That leaves me with v minus 2. Then I want to factor my denominator right here. What two numbers multiply to give me positive 18 and add to give me negative 11? Negative 9 and negative 2. Okay? Now I want to factor this numerator. What two numbers multiply to give me -9 and add to give me -8? Now, y'all don't even act like y'all tired now because I heard all that commotion when I was out in the hall. It's a number game, right? What two numbers multiply to give me 9 and add, or sorry, -9 and add to give me a -8? Perfect. -9 and +1. And then there's nothing I can factor out of that denominator right there. Okay. Now, before I cancel anything out, I want to identify my excluded values. And y'all, that comes from anything in my denominator that had a variable. What are they? 9, 2. This is 15 times V. What can I not multiply that by? 0. If you've got a variable just attached to a number, you don't want to multiply it by 0. So that is restricted right there. Okay? All right, here we go. Now I'm looking top and bottom. What is exactly the same that I can cancel out? Now, it does not matter if they are on top of each other like those, the V minus 2's, or if they are diagonal to one another, these V minus 9's. What else can I do here? The V's cancel, the V's go away.
Could you divide that -15 by 15?
Uh-huh. Right here I can divide out a 5. That gives me a -1 and that gives me a 3. Just want to reduce my numbers as much as possible. Okay? And that's it, y'all. I've got a -1 and then I have a V plus 1. And then down in this denominator, all I have left is that 3. So we have to factor, identify excluded values, then cancel. Okay? All right, let's take a look at this one. Okay? Before I get too involved right here, I want to pay attention to this denominator, and I don't like it. I'm going to flip-flop my order, and I'm going to do what? Jenna, you okay? Did I scare you? Make sure you wake up. I'm going to factor out a -1. That changes my signs. Okay? Next, I'm going to factor my numerator. What two numbers multiply to give me -36 but add to give me -5? Perfect. -9 and +4. And then the bottom denominator right here just has a GCF. Okay? That GCF, I can take out a 4P, and that leaves me with P plus 4. So, excluded values. P is not allowed to equal what?
9.
Okay? Okay? Perfect. Great job. All right. Then it comes to canceling. What do you see that I can get rid of? Okay, those are directly on top of each other. p minus 9s. Okay, those are diagonal, but that's still okay. And then that's it. Okay, now, so what I have left is the p plus 10 in the numerator. Do not forget this negative that's out here. Okay, so I'm going to put a negative out in front of, and I don't need parentheses there, negative 4p. Okay. All right, let's talk division real quick. Okay. Dividing fractions or rational expressions, okay? There is an additional step, okay? To divide rational expressions or just fractions in general, we multiply by the reciprocal. Now, to get the reciprocal or to do this properly, we typically say keep, change, flip. Keep, change, flip. So, keep the first fraction the same, change the division to multiplication, and we flip the second fraction upside down. We change it to its reciprocal. You can multiply and then simplify. Here I can divide out a 2. That gives me 9 over 4. Okay? Keep, change, flip. Keep the first fraction, change that one, flip to the reciprocal. You could also simplify before you multiply. So this gives me 3 over 2. And that still is 9 over 4. Either way, we still get the same answer. Okay? Now, here is one little thing we got to make sure that we do, though. Okay? Whenever we're dividing, whatever we're dividing by, this is my original denominator, so that affects my excluded values. But once I flip it, this is my new denominator, right? So we've got to identify excluded values using both of those pieces, okay? All right, real quick. Keep, change, flip. I'm going to keep this as 5pq over 16p cubed. And then I'm going to change this. I'm going to change that to multiplication. And then the 8q to the 5th goes on the top. The 35p squared q squared is in the bottom. Now, excluded values here. Whether it was my original fraction or the flipped one, p cannot equal 0 and q cannot equal 0. Okay, those are the only restrictions. P and q, p and q. I still have the same things right there. Would y'all be okay if I simplified my numbers before I got going? I feel like that'll give me smaller things to work with. 5 and 35, I can divide out of 5. That gives me 1 over 7. And then the 8 and the 16, that becomes 1 over 2. So right here, I have 1 p q to the 6th over 14 p to the 5th q squared. Now I know I'm not done because I've got these p's and I've got these q's that I need to simplify. There's only one p in the top. So what am I left with and where?
fourth.
P to the fourth, and where does that go? In the bottom. Perfect. You gotta trust yourself. Okay? All right, now, so in the bottom I've got 14 and I have P to the fourth. But then right here I've got this Q to the sixth over Q squared. How many do I have left and where? Okay? And I'm done. Because nothing else simplifies right there. Okay. Now, I am paying attention to this one, that there is division. So I know that this fraction is going to change to its reciprocal. I'm sorry, hon. Did I move too fast? Okay. I want to factor and flip at all the same time. Okay. So right here, this first fraction, the 10 doesn't change. You can factor out a 4, and what does that leave you with in those parentheses? X minus 2, okay. All right, now I'm going to multiply this by, all right, I'm going to start right here with my new numerator. That comes from this right here. What two numbers multiply to give me negative 6, but add to give me positive 1? 3 and 2, but which one has to be negative? The 2. Do you agree that 3 minus 2 is 1? Okay. All right, and then my new denominator, I am taking out a GCF of 2x, and that's going to leave me with x plus 3. Okay, now for my excluded values, okay, not only am I looking at my denominator for this second fraction, but I'm also looking at my numerator because this was in the bottom to start with. You've got to consider your starting fraction and your ending fraction. So what all connects not equal? Negative 3, 2, and 0. All right, so I got the 2's, I got the 0, I got the negative 3. Up here I've got negative 3 and positive 2 also. We just got to check everything. And now I want to simplify as much as I can. I've got these x minus 2's that go away. I've got the x plus 3's that go away. What else do I have? I know y'all are not packing up. The 4 and the 10, that becomes 5 over 2. So y'all, I have 5 over 4x, and that's all I have left. How did I get 4x? The other 2x that was still there. Okay? All right. There are a couple that I will need to go through with you. Are we 40 today? Oh, okay. Here we go. Let's take a look at these two, and then we'll end. Okay? All right, here we go. Keep, change, flip. I'm going to do as much as I can at one time. Okay? The first one, I'm going to factor out a GCF of 2a squared. That leaves me with a minus 6. The bottom factors into a minus 6 times a plus 2. Because negative 6 times 2 is negative 12, and negative 6 plus 2 is negative 4. Now, I am multiplying by the reciprocal. So that means what was in the bottom is now up top. This is a minus 5 times a minus 3. Now, if you look at this, you'll see that I don't like it because it's not in order, and it has a negative leading coefficient. So I'm going to take out a negative 8a squared. That leaves me with a minus 3. And I've got to look at my denominator and the numerator of my flipped fraction. So I know I've got 6, negative 2, 0, 3. I've already got the 3 for that one, and also 5. That's a lot of them. A minus 6's cancel. A minus 3's cancel. The a squareds cancel. And then 2 over negative 4 becomes 1. I'm sorry, 2 over negative 8 becomes 1 over negative 4. Okay? So I have a minus 5 over, don't forget your negative 4, I would stick it out front. You just have to be really careful and make sure that you don't leave anything out in the end. Okay? I feel like that's the hardest part of this. Okay? All right. Real quick with this one. Even though this is not written as a fraction, I can write it as one. Now, I am paying attention because I have multiple things going on here. I'm paying attention to those signs. The only thing that is going to flip is this second fraction because that follows division. I'm going to change that to multiplication, and that becomes 1 over 4k plus 1. This one does not flip because it followed multiplication. But it is a difference of squares, so it factors into 4k plus 1 and 4k minus 1. My excluded values are 0, negative 1/4, and negative 3. The k plus 3's cancel. The 4k plus 1's cancel. Well, I have 4k minus 1 over k. Don't cancel those k's, right? That's it. I don't need that. Because if I multiply anything by 1, it just stays the same. Okay? Great job.